Good evening, my 11th standard warriors. Welcome aboard to the lecture number 3 of fluid mechanics. We have seen fluids which are stationary, that's hydrostatics. Today, it's time to see what happens when liquids or gases move and how does an aeroplane fly. All these questions answered today with me, your favorite Captain Shreyas, going live for all of you in the Nurture series. Welcome aboard to the fluid dynamics session and let's get into motion really quick. By the way, those of you who do not know me, I am Shreyas. I'm the physics master teacher and you can also call me Captain Shreyas, and I have taught almost more than 10 years, and with this experience comes a lot of enthusiasm and a lot of things that you can learn from me to make physics more interesting. So what are we going to learn today? In this lecture number 3, the first 2 lectures we have spoken about static fluids, buoyancy, flotation, hydrostatic pressure, barometer, manometer. In case you have missed that, you can definitely watch it. Today we're going to see what are the different kinds of flow associated with fluids, also the different parameters associated with the flow, the continuity equation and Bernoulli's equation, and yes, we're going to apply Bernoulli's equation in Torricelli, Venturi meter, Magnus effect, and so much more. So welcome aboard all my warriors, and if you're here, I am really glad that you are on the right channel, which is your one-stop solution for all the preparation that you need for JEE, KVPY, BidSat, boards, you name it. So welcome NV18. Hi Ishpreet. Good evening my warriors. Some of the 12th standard students are also here, like you can see, because they want to revise through the concepts of 11th. So you're most welcome. Hi Simran. Hello Jayavant. Long time no see. So I'm guessing most of your exams are going to get over this week. So make sure once your exams are over, if you're watching it recorded, make sure you watch the previous sessions as well, because before Christmas, yep, you heard it right, before Christmas we're going to complete fluids, that's viscosity, surface tension, everything, so that when we start with new year, we hardly have 2 chapters to go. That's thermo and waves. That's it. 2 big chapters. Welcome Dakshin. Hi Sai Kiran. And thank you for smashing the like button and thank you for hitting the subscribe button. If you have not yet hit, please do that, because then you will miss my further classes and all the important announcements and updates, as well as KVPI preparation. So I hope you are all set to start fluids in motion. Oscillations is already done, NV18. It was done just, last week. SHM, oscillations, is completely done. It's over. Hi Shubham, good evening Bacha. Hi Molesh, hi Meera, good evening. So here is the thing. See, in fluid statics, the fluids were at rest and you saw that the net force acting on it was 0. But the moment fluid starts moving, it can behave in a crazy manner, like this river out here. Look at the fluid particles, so many of them going randomly here and there. It's very difficult to analyze that motion, right? So what we need to understand that fluids in motion itself is a very complex subject. There is a separate branch of engineering associated with it. Which is that branch? That is, yep, you thought about it right. Yep, it is called as aeronautical engineering and also naval engineering, and also if you take up chemical engineering and also automobile engineering, you will be dealing with fluids as a separate subject. It's a vast subject. In JEE, we are going to scratch the surface. We are going to study the most fundamental laws, like when you were back in 8th grade, you start studying about what is liquid, what is gas, what is force, and what is motion. So you start getting a brief idea, and then when you come to 11th standard, then you get the concept. So something like that. But nevertheless, there are very good numericals out here. First of all, what is a streamline? See, whenever liquid flows, there are particles in that liquid. So imagine there is a flowing liquid. So if you have a flowing liquid, you will have particles in that liquid So there could be many particles. Each particle will take some path. This is the path taken by the particle. This particle might take this path. This particle might take maybe this path. Maybe this particle takes this path. Maybe this particle comes over here and continues with this path. Maybe this particle takes some other path. Maybe some other particle over here might reach here and then continue this same path which was taken by the particle over here. So every time a particle comes, it takes a path taken by the previous particle, or it might be on some different path altogether. These paths are nothing but called as streamlines. What are they called? Streamlines. That's very important. So streamlines is a hypothetical concept. It's a hypothetical concept to understand the flow of liquids. It gives you an idea of how the flow is, how the path is, what are they trying to do. Also, remember, if you draw a tangent to the streamline, if you draw a tangent, that tangent gives you the direction. It gives you the direction of the velocity. So it will give you the direction of the velocity. Perfecto. Hi Vivek. Good evening, bacha. Yes, Sai Kiran. It's the moving path of the liquid. Okay. So Harshini, I'll definitely help you out. Either stay till the end or maybe message me on my Instagram handle. That's Shreyas_Vedantu. Don't worry. Now, I have a question for you. Imagine the velocity at this point is v1. Imagine the velocity at this point is v2. Imagine the velocity at this point is v3. What do you think? Is v1 equal to v2 is equal to v3, or is it not equal? What do you suggest? What do you guys think about it? On a particular streamline, do you think the velocities are equal or are they not equal? Come on, let's see how many of you can get this correct. Figure this out. Are the velocities going to be equal or not equal? Okay, Prakash says not equal. Okay, so Kesav, by next month end, by January end, our syllabus will be done. Yep, not equal. Okay, wow, you guys are smart, man. Okay, now I'll explain to you why they are not equal, but before that, I have another question for you. Is it possible that there is one streamline here and there is another streamline here and they intersect each other? Is it possible two streamlines intersect each other? Is it possible or not possible? What do you guys say? That is it possible or not possible? Think about it. If they intersect, I will have two tangents, and if I have two tangents, I have two velocities at the same point. How can a particle have two velocities together? Is it possible? Not possible. I'm Shreyas, I'm Captain Shreyas. I have velocity here and I have velocity here. Not possible. Either I have this or I have that. I can't have both. So you can only go in one particular direction. You can't go two ways, or else I'll split into two twins. That's not possible. So they cannot intersect each other. So what we learned, streamline is nothing but the flow or the path of a particles, and the tangent drawn gives you the direction, and two streamlines can never intersect. Talking about the velocities, whether they are equal or not equal, the answer is they are not equal, and the reason why they are not equal is because, understand, the liquid might accelerate. The liquid might accelerate or even decelerate. It's possible. You are going and suddenly the flow speed increases and suddenly the flow speed decreases. You would have always seen that in case of a pipe or in case of a river. Sometimes the river is very fast moving, sometimes it is very slow. So the same particle might gather speed or might lose speed depending on a lot of other constraints. So the speeds may or may not be equal. Okay, these speeds may or may not be equal. I hope this is clear. That brings us to something called as steady flow. Yes, Jitesh, I do remember. Alright, so Ritik, just leave a comment after the session ends. I'll definitely respond to your comment. I want to maintain the flow. Steady flow. In fact, I want to maintain this steady flow. I don't want to be turbulent. So what is the meaning of steady flow and what is the meaning of the other kind of flow which is called as the turbulent flow? This is a very good animation to describe it. Look at this tap. You would have definitely seen this kind of flow in your bathroom, especially if you have a tap at a good height. When the water comes, it comes with nice, smooth, cylindrical surface. Have you seen that? Most of the times, if you arrange the tap valve very carefully, you will see the water or the liquid will come in a very smooth manner. But as it comes down, then it splashes over everywhere. You will see some waviness, you will see some randomness associated at the bottom. So what is it? Basically, when I say steady flow, it means it is predictable flow. I know what is going to happen. It's not random. I know that for some reason, for example, there is a particle 1 over here. It starts from here and follows this streamline. I know if some other particle comes over here, it will follow the same streamline. If another particle comes over here, it will again follow the same streamline. If new particle comes, again it will follow the same streamline. But in case of a turbulent flow, which is not a steady flow, so what happens if you have a particle 1, it might follow this streamline. After some time, if a new particle comes at this point, it might go like this. After some time, if a new particle comes over here, then it might go like this. So, it might go in random directions with time. The flow changes with time. It is not predictable. And in JEE, we study predictable flow. The science, the physics of the turbulent flow is quite complex. And you will have to graduate to and take very special branches to study turbulent flow. For now, we are going to study only steady flow. So in steady flow, the speed does not change with time, neither does the direction. It's very predictable. I know if the particles are going this way, even if I come after a few minutes and look at the water particles there, they will be going in the same direction. It will not change with time. Okay, I hope this is possible. Okay, NV18 has asked a very interesting question. Is intersection possible in turbulent flow? Very interesting. It looks like they are intersecting, but think again, they are not intersecting at the same time. When a particle goes like this, after some time, a new particle might cross its path. But by that time, the original streamline is destroyed, it's gone. So they are intersecting at different times, not at the same time. No two streamlines can ever intersect at the same instant of time. I hope that makes sense. Okay, yep. There is a Pandu flowing in water current to check whether the flow is steady or not, and we have to apply partial derivative. Yes, Bichara Pandu has to do so much of activity to figure this out, and don't worry Rakesh, to help Pandu to figure out whether it is steady or not steady, Reynolds is going to help him out. And what is Reynolds' formula? We are going to talk about it in viscosity. Okay, yes Samuel, why not? I do remember you, and plus you have the lovely display picture. So the moment you put up that display picture, you catch my attention, let me tell you. Look at this flow, it's so satisfying. Aren't you like satisfied looking at this? Oh my God, look at this. This is steady flow. You are in love with this flow. You don't like the water to go in a haphazard manner. You don't want it to be turbulent. It's so lovely. Yes, Ashika, I did complete solids. You should definitely check out the lecture. There is going to be one more class on solids for problem solving. Don't worry about it. Beautiful. This is steady flow. Now that we are talking about steady flow, let's talk about equation of continuity before jumping to problems. So stay tuned. Yep. Yes, Vignesh, it is. It is. Enough. So this deals with something. So we are going to deal with equation of continuity. Very important equation. One of the most important equation in this chapter. Now look at this flow. Steady flow, predictable flow, right? Look at the pipe, it's very wide. Look at the pipe here, it's small. Okay, now you might be like, sir, how is the liquid floating in air? Guys, this is just the cutout visualization to show you what is happening inside the pipe. Don't think, sir, water is floating in air, sir, how is this possible? What is the physics behind it? Only Rajnikant can do that. And at least right now I'm not Rajnikant. Alright, so the thing is, it's going from here to here, the cross section is changing. In fact, the speed is also going to change. Believe me. Yep, the speed won't remain the same because the area is changing. And we are going to see the relationship for that. And what is it? See, Imagine you take a cross section. You take a cross-sectional element. You take a cross-sectional element of thickness dx. So how does it look like? It looks something like this. This is your thickness. I hope you can see that. This is that thickness right over here. Beautiful, isn't it? Okay. Now this is essentially dx, that is having certain velocity v, and that area of cross section is a. That's what it is. Now this section will have certain mass. So this is some section. It could be here, it could be here, it could be here, it could be there. It's just a slice of that liquid. This slice will have elemental mass. This is a small element, so elemental mass. And what is the elemental mass? It will be dm, correct? And this dm will be density into volume. And what is the volume? The volume will be area into dx. It will be area into dx. So if I ask you what is the mass flow rate? What is the mass flow rate? The mass flow rate is the mass which flows per unit time. That means dm by dt. That means dm by dt, mass per unit time. How much mass is flowing per unit time? Kgs per second. How many kgs of liquid is flowing per unit time? So this will become rho a dx by dt. Rho a dx, that's what it is, divided by dt. Now what is dx by dt? It's very obvious, because velocity will be position change with respect to time. So hence this is going to be just rho a v. So this is mass flow rate. So you can call it Rm. R stands for rate. This is mass flow rate. So very, very important formula. Very, very important formula. It is rho a v. Keep this in mind. Keep this in mind. I'm so glad, champion. It's helping you. Very good. And Rakesh, yes, you're right. Now, here is my point. Do you agree or disagree that whatever mass flows in per unit time should be the mass which flows out per unit time? Think about it. Whatever mass, whatever is the rate of mass flowing in, shouldn't it be equal to the mass which is flowing out per unit time? Because if I put in 5 kilos of water in 1 second, 5 kilos should come out in 1 second. Alright? Because if it doesn't, let's say you put in 5 but you only get 4, that means there is a leakage in the pipe and the water is getting drained out. Nor should it be 6, because if you are putting in 5 and you are getting 6, that means somebody is adding some water silently. Very, very smart. So basically whatever you put in should come out. So that means rho 1 a1 v1, whatever is this value at this particular point, should be equal to rho 2 a2 v2. Makes sense? So this is one way of writing the flow rate which is going in and flow rate which is going out, and we are seeing that it is continuing. Whatever is the flow rate, that flow rate is maintained here, 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 and wherever you measure it in that pipe. So basically that is why it is called as continuity equation. It is continuing. It's not leaking or it's not being added. So continuity equation. But most often you are going to find that the density will be equal. Like liquid, the density does not change. Ideal fluid. So in case of ideal fluid, what will happen? For an ideal fluid, density is constant. If the density is constant, then what will happen? Rho 1 and rho 2 will get cancelled. So I will be just left out with only a1 v1 will be equal to a2 v2. That's it. That's our final answer. So most often you're going to use this equation and not this equation, because the densities will be equal. So no point writing it down. Is that making sense? Is that making sense? Pujita, for theory, watch Pathfinder. Watch the Pathfinder series. I have done in detail theory. So that's why you should watch Pathfinder. Number 2, the theory will be done as concepts of problems when we solve the problems. Perfecto. Can we write Q1 is equal to Q2? Yes. Some books use the symbol Q instead of R. Some books use the symbol V. V, R or Q. Doesn't matter. All are same thing. It just means flow rate. Mass flow rate, volume flow rate, whatever you want to call it. So fair enough. Mass flow rate is rho AV. Rho 1 A1 V1 is rho 2 A2 V2 when the density varies, but if the density does not change, then it is just A1 V1 is equal to A2 V2. This is just coming from the law of conservation of mass. Mass cannot be created nor destroyed unless you convert it into energy, but that's not what is happening out here. Perfecto. Excellent. Janya, the VMSAT syllabus is there in the FAQs. Just check it out. Just open the FAQs. When you open the site, if you scroll to the bottom, you're going to find the exact syllabus. Just go through it. Here's the first question coming up on your screen. Let's see how many of you can do this really quick, my warriors. Okay, water is flowing through a channel that is 12 meters wide. It's a channel. Channel means something like this. Okay, try to visualize. So just imagine this is a channel. Okay, the width is basically how much? The width is 12 meters. The channel. Okay, so the liquid is flowing like this. Okay, now this is the top view. The channel divides into 4 parts, each of width 4 meters. The depth of the water does not change. Okay, so the depth of the water does not change. What is the speed of the water in any of the smaller channels? Let's see how many of you are really quick in solving this. Come on, figure this out, my warriors. Think about it. What is the answer? Now, over here, the given data says the channel width, okay, the width of the channel is basically 12 meters. The speed is 0.75 meters per second. Here the speed is V, V, V and V. And here the width is nothing but how much? The width is, the width is nothing but 4 meters. Okay, I think the width is 4 meters, correct. So think about it. Whatever water is flowing in should be the water which is flowing out. The water which is flowing in is area. Now the area will be width into depth. The width is 12, depth is, let's say, D. So 12 into D is the area of cross section. I hope you visualize this. This is the top view. So there is some depth associated with it. So depth into width will give me the area into the speed, which is nothing but 0.75 is equal to the liquid is flowing out at 4 different places. 1, 2, 3, 4. All of them are of the same width, same height, same speed. So I'll multiply this by 4 because it's branching out into 4 parts. So R1 plus R2 plus R3 plus R4, all of them are equal. So 4 times. And each of the volume flow rate will be area. What is the area? Area is 4 into the depth, which is D. Okay, this is the area of each part into V, of course. Now just do the math, you will get the answer. You can clearly see that this D and this D gets cancelled and you will be getting 12 into 0.75, which is 12 into 3 by 4 is equal to 16 into V. So V is equal to this 4 and this 12 goes like this. 3 3s are 9, so 9 by 16. So it will be so 16, yeah, 5s are 80 and then you have that 10, so 16 6s are, so 0.56. 0.56 should be the answer. Yes, my classes are at 7 o'clock. No, Alna, it's not 2.25, it's 0.56. Be careful. Yep, perfecto. Hi, good and bold world. Welcome aboard. Excellent, my warriors. Some of you have got it. So, whenever there is branching, so on the RHS, it will not be A2V2. It will be A2V2 plus A3V3 plus A4V4. How many ever branches are there? That's what will happen. All right. So that's what I have done over here. This 4 is because there are 4 branches out here. Okay, rest all is simple, basic algebra. Moving on to the next question coming up on your screen. Now this one is slightly tricky. It looks complicated, but trust me, it is fun. What is happening is there is a U tube and the tube is moving in water. The tube is moving in water with speed v, but the water is at rest, or the liquid is at rest. The area of cross section of the top part is S2, area of cross section of the bottom part is S1, and density is given. Neglect the difference of height, and velocity of the liquid which comes out from the top as seen by an observer on the ground will be. Observer on the ground will be. Okay. First of all, here is what I am going to do. Choose a reference frame. I will not sit on the ground and solve the problem. That's the trick. Because if I sit on the ground, this water is at rest. The water which is in this tube might not appear to move. So here is what I'll do. I will sit on the tube frame of reference. So what is my frame of reference? I will sit on the tube. So the moment I sit on the tube, then I won't have this velocity. I won't feel that the tube is moving. In fact, I'll feel the water is coming onto me. So when you are in the ground frame, you see the tube going. But when you are on the tube, you see the water coming towards you. Makes sense? Now things become easy. How? Observe. Because you feel that the water is coming onto you like this. The liquid will come onto you with how much speed? With v speed. Now it becomes easy to solve because the liquid enters this cross section with speed v. It goes like this and it goes out. So liquid is coming into you with speed v. It goes in a broader cross section, turns and goes out in a smaller cross section. So maybe it ejects itself out with some speed u. Okay, so this is u. Okay, this is u. So we can find u very easily by continuity equation. So using continuity equation, because it's a continuous flow, you can see that. So that means area of cross section, which is S1, into speed, which is v, will be equal to area of cross section, which is S2, into u. Therefore u will be equal to S1 by S2 into v. Remember, this speed, this is the speed with respect to the tube. This is the speed with respect to the tube. So if I ask you the velocity with respect to ground, the velocity with respect to ground, do you think it will be u plus v, v minus u, u minus v? What do you guys think? Think carefully before I start writing it down. No, Sai Kiran, A is not the answer. Let me tell you. Remember, this speed is with respect to ground. The question asked over here is as seen by an observer on the ground. So we need to find out velocity with respect to ground. So A is there deliberately because students are going to mark it and that will be the wrong answer. Okay, so a lot of you are going to mark that. That's not correct. Think, with respect to the tube, let's say I am the tube, it's going with u. With respect to the tube, it is going with u. But tube itself is going with v. Tube itself is going with v. With respect to tube, it is going with u. So what is the speed with respect to the ground? Or you are the observer on the ground. Think, the tube moved with v. With respect to tube, it moved with u. So how much did it exactly move? Think about it. Think about it. It moved v plus u. Is it not correct? Understood, my warriors? So hence it will be v plus u. That means it will be v plus s1 by s2 into v. V is common, so 1 plus s1 by s2. Is that option there? Yes, it is. Option B it is. It is option B. It's not C, Shyam. Be careful. Is that now understood why option B is correct? So this is one very interesting problem on continuity equation. So the first step was to sit on the tube and observe the water coming in with speed v. So the water goes in with speed v, it comes out with a new speed u, which we found out. But that's with respect to the tube. Because the tube itself moves with v and with respect to it, it moves with u. So you have to add them to get the final answer. So that's how beautiful this question is. Very tricky, says Sai Karan. Very good, Prakash. Very good, Shyam. Now moving on to the next part, but before that let me tell you, if you have forgotten to join our new Telegram channel group, make sure you join it as early as possible. Yep, because all the updates and all the important PDFs are going to come there. And also remember, for the 11th standard kids, we have a crash course which is running right now for all of you to completely revise the entire 11th standard syllabus with the test series, with assignments, with the doubt solving, and with the best teachers just like me. So go ahead, you can also get my courses free of cost when you are in the pro subscription. So check out the link which is there in the description box below. It's now time to move to Bernoulli's principle. Now, it has amazing applications. You will be really amazed. It's really amazing to see all the applications of Bernoulli's principle. Now, what is this Bernoulli's principle based on? It's just based on one simple thing. That is energy conservation and certain assumptions about the liquid. That's it. What are those assumptions? I will talk about it. So here are the assumptions that are used for Bernoulli's principle. The first assumption is that the liquid, okay, is not compressible. You cannot compress it. It's not compressible. Okay. Number two, the flow is predictable. So that means if it is predictable, the flow is essentially steady. So the flow is continuous, steady. Number three, the important assumption is that it is not viscous. It is not viscous. Viscous means there is drag, like honey or sauce or ketchup. You throw it on a table, it hardly flows, it stops. Water is less viscous, it flows very easily. So an ideal fluid will have negligible viscosity. When you throw it, it just keeps on flowing. It's very fluidic. So there is no viscous forces which stop the flow. The last thing is that the flow is irrotational. Irrotational. The meaning of irrotational is when the fluid particles are moving, they just have translational velocity, but they do not have rotational angular velocity. So the fluid particles just go as it is. They are not rotating, spinning about its axis, because the entire principle, like I said before, is just based on energy conservation. It's just based on energy conservation. So that means energy at point 1 will be equal to energy at point 2, will be equal to energy at point 3 in that same tube, no matter where you go. This point, this point, this point, this point, all have the same total energy. So we only account for the translational energy, we do not account for the rotational energy, which is a very fair assumption because the rotational kinetic energy in a moving liquid, most often it is very negligible. So it is fine. Yes, paint is very viscous, Shyam. Correct. It will be for ideal. Yes, Vivek. These are all the assumptions for ideal fluid, and this is completely based on energy conservation between 2 points. Now look at this particular liquid. This is an open section that is just showing you how the liquid is flowing through a pipe. Here the cross section is different. Here the cross section is different. This is at a lower height. This is at a much larger height. Here the pressure in the liquid could be different. Here the pressure could be different. So there are 3 kinds of energy that you should be aware of when you have a moving liquid. Yep, you should be aware of 3 kinds of energy in a moving liquid. So what are those 3 energies? One is pressure energy per unit volume. The second one is hydrostatic energy or potential energy per unit volume, and the third one is basically kinetic energy per unit volume. So the 3 forms of energy are the hydrostatic pressure, the pressure energy, okay, so pressure energy per unit volume, okay, per unit volume, and then you have gravitational potential energy per unit volume, and the last one you have the kinetic energy of that liquid per unit volume. These are the only three kinds of energy which are there with a liquid, and the sum of all of them is going to be a constant. What is it? The sum of all of them is going to be a constant. So at this point, the pressure energy plus gravitational energy plus kinetic energy per unit volume will be pressure energy plus gravitational energy plus kinetic energy at this point. So their sum remains constant. Yes, BN gamers, you can still join. You can even slide back a little bit, even in a live class, and you can catch up at 2x speed as well. So this is what is constant, and the value of this pressure energy per unit volume is just the value of P. So pressure energy per unit volume is P. You can check it dimensionally as well. It comes out in joules. Gravitational potential energy per unit volume comes out to be as rho GH, and kinetic energy per unit volume comes out to be as half rho V square. Half rho V square looks like kinetic energy. Instead of mass, you have density. Instead of mass, you have density. That's it. So whenever you have a pipe which carries some liquid and you find that there are two cross sections, you can immediately apply Bernoulli's principle between any of those two cross sections of a pipe or some flow or some tube. And keep in mind, this energy plus this energy per unit volume is a constant, and these are the values. So if I had to apply it over here, it means P1, which is pressure energy, plus gravitational potential energy, maybe rho G, let's say this is H1. You might be wondering, sir, H is measured from which height? You can take any arbitrary line. This is some kind of reference line from which you are measuring all the heights. Doesn't matter. Plus half rho V1 square will be equal to all these terms again for that cross section. So P2 plus rho GH2 plus half rho V2 square. This is what you will get. This principle, which is based on energy conservation and those four assumptions, is called as the Bernoulli's principle, and you can apply it for any tube, okay, where the liquid is flowing. Yeah, Vignesh, by January end, definitely. Especially, yes, term 1 is finally over and we are now into term 2. We have already completed how many chapters? Are you guys aware of it in Nurture series? Ruchi, yes, you will be able to understand because hydrodynamics is a separate chapter altogether. But yes, after today's class, watch the first two classes. We have already completed solids. We have already completed hydrostatics. We are on to hydrodynamics. We have completed oscillations, that is SHM. And now we are slowly going to move towards viscosity and all of that in the next few classes. Now that is what Bernoulli's principle is all about. Pressure plus rho GH plus half rho V square is constant, and you can apply it at two different cross sections. Now, yes, can a NEET aspirant crack JEE with physics and chemistry? No, Tushar, you need bio also. Can you crack JEE with physics and chemistry alone? It's a little difficult. You can crack it just for the sake of passing, but getting into a good college might be difficult. Okay, what is pressure energy? So basically, think of it this way. Whenever you have this liquid, it has some pressure here. The pressure is forcing it inside over here. Okay, so that force of pressure is doing some work. So that work done by the pressure forces, per unit volume is called as the pressure energy. I'll repeat, there is pressure of liquid over here. So that force due to the pressure per unit volume is called as the pressure energy. Alright, think of it like that. Or hydrostatic energy, think of it that way. Alright, is that clear, my warriors? Fair enough. Now you will see one interesting thing. If by chance, let's say one of these terms increases, then you will see other terms will have to decrease. If this term maybe increases, maybe this term decreases, maybe this term increases, but they will make sure that they are constant. Now imagine that the pipe is just horizontal. Imagine the pipe is just horizontal. If the pipe is just horizontal, then what will happen? The height term will be same both places. Do you guys agree with it? Rho g h1, rho g h2, both will be equal because the pipe is horizontal. The cross section could be different. That means only we have two terms over here. What do we have? We have only two terms over here. So if the speed increases, what should happen? The pressure should decrease. Agree? And if the speed decreases, the pressure should increase. This is very interesting. And I'll give you a very interesting application for that. So if speed increases, pressure decreases. Speed decreases, pressure increases to keep their sum constant. Observe this particular phenomena. I'll just remove this and I will just put over here, if H is constant, then pressure plus half rho v square is basically a constant. Just imagine this is your Pandu, okay, and he's just staying at home. This is Pandu's house, okay, this is Pandu's house, beautiful house Pandu has, and he sees that there is tornado, there is a big storm coming in. He decides to stay in his house. So winds are blowing at very high speeds, very high speeds. So this is the wind which is coming in and it is blowing at very, very high speeds, okay, like this. Now as the winds blow over his house, you will see some of the wind streamlines will get obstructed, and over here maybe they slowly leak out here, and here they just get trapped. Basically they just get trapped inside his house somehow. So here the speed of the wind is low. The speed which enters inside the house somehow is very small because it's trapped, it's slowly coming inside in haphazard manner. But here as the air goes on the top, you can see it is unobstructed, so the speed of the wind is high. And what did I tell you about speed and pressure? If the speed is more, then the pressure is less. Speed is more, pressure is less. So from the top you have low pressure area, and from the bottom you have high pressure area. So what happens now? You have low pressure from the top, high pressure from the bottom, so you will have more force from the bottom as compared to the force from the top. That means what will happen to the roof? The roof will just blow off. And Pandu will be like, what the hell just happened? So this is the reason why the roofs blow off, and the answer for that is, the Bernoulli's principle. Okay, so that's what it is. Okay, so Dominic, you need to do theory and MCQs both. You cannot do just theory, you need to practice problems. Without problems practice, you will never understand the theory, bacha. And you will not be able to solve problems when you solve it for KVPY, JEE and so many other examinations. Yes, even burns and burners, all the applications like sprays and an aeroplane flying is all based on Bernoulli. Now look at this, wow, gigantic, paper aeroplane or wooden aeroplane, and look at the way it is flying and why does it exactly fly. So this is a cute looking aeroplane. Now you might be wondering what keeps the aeroplane afloat, because the engines are horizontal, they just suck in the air and throw backwards. There is nothing actually pushing it below. Now yes, the wings make it fly, but do you know there is a special shape of the wing which makes it fly? And the shape of the wing is something like this. Look at this. The wind, so this is the cross-sectional area of the wing. This is the wing over here. If you look at it from here, this is the wing's shape. If you look at it from that side, the wing looks somewhat like this. This shape is such that, it's called as the aerofoil design, and you have a special branch just for it to design these aerofoils. Okay, so when you enter IIT and ISRO and all of that, and the air which comes from that side is cut into two streams. What is it done? It is cut into two streams. The stream of air which goes from the top, the stream of the air which comes from below. The shape is such that the stream which goes from the top has higher speed. So that's how the shape is. And the stream of air which goes from below is made to slow down. So I'll repeat, the stream of the air which goes from below is slowed down because of its shape, and the one which goes from the top is fast. What did I just tell you? High speed, low pressure. Low speed, high pressure. So the air which is faster has low pressure on the top, and the air which is slower has high pressure from the bottom. So if there is high pressure from the bottom and low pressure from the top, obviously the higher pressure will create this lift. That's what happens. This one, the class started at 7 o'clock. So this is how it flows, and this is how it flies. So this lift is basically due to the pressure difference into area. So because lift is nothing but the force due to pressure difference, due to the pressure difference. So this lift is the pressure difference into the area. If you want to calculate the pressure difference, it's very easy. Just use Bernoulli's principle, half P1 plus, P1 plus half rho V1 square is equal to P2 plus half rho V2 square. So you can clearly see, you can calculate P1 minus P2 is equal to half rho V2 square minus V1 square. So this is how you can calculate the pressure difference. So you know the speeds at the top and at the bottom. So if you know that and you know the density, you can calculate the pressure difference multiplied by the area, you get the lift. Very, very cool. And this is the only reason why the aeroplane flies. There is no other reason, let me tell you that. Okay, so that is why the shape of the wings matters a lot. And if there is some ice, which has frozen on the wings, it is very dangerous for the plane, because if the ice gets stuck on the plane, then it might affect the shape, it might also affect the flow, and it might also affect the pressure difference, and it might not create sufficient lift, and then the plane will plunge down. So you don't want that to happen. So that's why there are de-icing systems on the plane. Good enough. Let's talk about something called as the Magnus effect, which is also related to the swing. NV18, we are going to have terminal velocity as viscosity in a separate chapter. Okay, so yep, definitely Tushar, Nurture and Pathfinder will be good enough for you, Tushar. Hi Sushila, good evening. If you take a ball and spin it, you will see it bends. It will go in a curved path. Have you observed that, my warriors? Have you observed that? If you take a ball, spin it, you will see it goes in a curved path. What is the reason for that? Let's try and understand. So imagine somebody throws a ball, spins it, and in the air only it turns somewhere else. That is called as the swinging effect or the Magnus effect. So observe this. What is happening? This ball is made to rotate. Okay, so what is happening? The ball is made to rotate and it is going like this. So this is where it is translating and this is where it is rotating. So it's made to rotate like this. From the frame of reference of the ball, understand the wind is coming against it. You can see the streamlines of the air coming against it. So the wind is blowing. The wind is blowing against the ball. Now the wind is cut into two streams. That air is split into half. One part of the stream which goes from the top, because of the spin, that air is pushed backwards. Look at this, the air is pushed this way. Because of the spin, the one which is in contact with the top part, it is pushed backwards. It's basically accelerated. Correct? The one which comes from below, because the ball's surface is going like that, the wind which is coming here will be stopped. It will be basically decelerated. So this one is decelerated, this one is accelerated. Are you able to understand this? Yep, I know, Vivek. There was one case which came out in Nat Geo aircraft investigations. I remember that. Now that's the case. Think about it. If the speed here decreases, what should happen? When speed decreases, pressure increases. So here you will have increased pressure. So that's why I have written down over here increase in the pressure because the speed decreases. Whenever speed increases, the pressure decreases. So you will see decreased pressure over here. High pressure from here, low pressure from here. So what will happen? It will have a net force on this side. The net force will be on this side, and that's why the ball will turn that way. I hope this is clear. This kind of question was asked in JEE. They had given one diagram. They had shown this is how it spins and this is how it is moving. Predict where will it tilt? Upwards, downwards, right side, left side. So a lot of people got confused. So it was completely based on Bernoulli's principle, Magnus effect. Is everybody clear? And I hope you have smashed the like button. In case you haven't, please do that right now. And yes, hit the subscribe button. The reason you need to do it is only then you'll be suggested next time to watch the video, or you might completely miss the next chapter, the next session as well. So a quick recap. The ball goes that side, correct? So from the ball's frame, the wind comes this way. The wind split into two streams, one going from the top, one going from below. The one which goes from the top, because of the spin, it is accelerated. The spin accelerates it. The one coming from below, it's opposed, so its speed decreases. Whenever speed decreases, pressure increases. So more pressure from here. So if more pressure is there from here, it will tilt towards that side. So net force will be there. I hope that makes sense. Let's solve some questions coming up on your screen. Here it is now. Figure this out. Is this turbulence related? No. No, Brock. This is not related to turbulence. All right. Chalo, let's have a look at this. There is a pipe of diameter 20. It has some constriction of diameter 4. The speed of the water is 2 and pressure is 10 to the power 7. Find the speed and the pressure at that junction. Okay, I hope this is clear. Think about it. How are you going to solve this question? Maybe we should probably get a diagram. Let's see if we can get a diagram. Yes, there is a diagram. Okay, let's write down everything. The diameter is 20 centimeter. Interesting. So this is the diameter, which is basically 20 centimeters. Constriction, that means a narrow point. So this is nothing but how much? 4 centimeters. Perfect. And here the speed is 2 meters per second. The question is, what is the speed here and what is the pressure at this point? Okay, I don't know, but the pressure at this point is 10 to the power 7 Newton per meter square. I think I can find out the speed very easily. What do I need to do to find out the speed? Think about it. What is that equation that you need? Continuity equation, right? So just use continuity equation, because this is a continuous flow in a pipe. So continuity equation. So if you use that, just use A1 V1. A1 V1 is equal to A2 V2. What is A1? Be careful. The area is not given, the diameter is given. And the diameter, think about it, the diameter and area is related by pi d square by 4 is the area. So it will be actually speaking pi diameter 1 square by 4 into velocity 1 into V1 is equal to pi d2 square by 4 into V2. Pi 4 cancels. V2 I don't know, V1 I know. So basically V2 will be equal to, think about it, d1 by d2 square into V1. d1 by d2, I just need the ratio, don't think about the units. d1 by d2, so 20 by 4, so that is basically 20 by 4 whole square into V1. What is V1? It is 2. So how much will it be? 20 by 4, that's 5. 5 square, 25. 25 into 2, 50. So it will be 50 meters per second. That's the answer for the first part. So velocity is done. Velocity is done. Everybody clear? 50 meters per second. So, yep. Yes, Vivek. So the ball follows the path because of the Bernoulli's principle. That is why it is called as the Magnus effect. Okay. Hi Neeraj. Good evening, bachalo. Yes. Will the direction of the wind change the direction of the flight? Yes. Wind can change. Here, the wind did not affect the motion. The wind was basically, the air was at rest. In spite of the air being at rest, the ball turned. That effect is called as the Magnus effect. If a wind is blowing, that is just because of the flow of the liquid carrying it. That's not called Magnus effect. Now the pressure. How do you find pressure? Use Bernoulli principle. So according to Bernoulli's principle, P1 plus rho GH1 plus half rho V1 square will be P2 plus rho GH2 plus half rho V2 square. The best part is horizontal pipe. If it is horizontal pipe, rho GH1, rho GH2 cancels. The heights are the same. The center and that center are at the same height, so ignore the heights, it will just get cancelled. P1 is given to be 10 to the power 7. So 10 to the power 7 plus half into density. What is it? Water. So water's density is 1000, okay, into V1. V1 is 2. So 2 square is equal to P2, I do not know, plus half into 1000 into V2. What is V2? V2 is 50. So 50 square. So therefore, P will be equal to 10 to the power 7. Here we have 2 square, here we have 50 square. So minus. Okay. So I can do one thing. I can put a minus sign. I can also put 1000 divided by 2 as common. And here I will put 50 square minus 2 square. See if this makes sense. Because once 50 goes on the other side, so it will become minus 50 square, and minus is plus. So minus and minus is just plus. So fair enough. So this will become 10 to the power 7. And let's see what we can do over here. 1000 divided by 2. 50 square, that's 2500 minus 4, correct? 2500 minus 4, that's going to be just 2496. And this will go half times. So this will be 1. 2, and then we have 4, and then we have 8. So I can write this as 10 to the power 7 minus 1.248 into 10 to the power 3, 10 to the power 3, so 10 to the power 6. So I can just write this down as 10, I can take it common from here, minus 1.248, the whole thing into 10 to the power 6. Fair enough. So 10 minus 1.248, correct? So that's going to be correct. Just check this out if everything is fine. Yep. Okay. So we can approximately take 248 as, we can just take approximately 248 as 25. Keep it till 2 decimals. You know, we generally find the answers till 2 decimals. So 1.25. So this will become 8.75 into 10 to the power 6 Newton per meter square. Just check this out. See if this makes sense. Everybody fine? Yep, Ishwar, I'm starting term 2 syllabus next week. Yep, so tomorrow you're going to have your sprint series, and then yes, you will have your continued term 2 syllabus as well. And yep, you're also going to see the continuation of Pathfinder. I've already completed light waves half and electromagnetic waves completely from term 2 for the 12th standard. So that's how you need to solve this. Yep, it is 8.75 into 10 to the power 6 and 50 meters per second. Perfecto. Everybody clear? Shall we go ahead to the next question coming up on your screen? Here it is. The question on plane, aeroplane. Let's see. A plane is in level flight at constant speed such that the speed of the air below is 144, speed of the wind above is 180 kilometers per hour. Each of the wing has 25 meters square area. Then what is the mass of the plane? Wow, what an interesting question. Let's have a look at this. But before doing anything, I know what to do. I need to first of all convert all these speeds into meters per second. So just multiply it by 5 by 18 to convert it into meters per second. Come on, do this. 18 and 144. Come on, what is it? Come on, my warriors. 18 and 144. Figure this out. Yep, 18, 8's up, 144, correct? And into 5. So that's going to be 40 meters per second. Perfect. This is 180. So again, just multiply it by 5 by 18 to convert it into meters per second. How much is it going to be? That's going to be just 50 meters per second. Just check this out. Fair enough, my warriors. Correcto? Now what is the next concept that you're going to do? Think about it. Didn't I tell you about, the wind which goes from the top and below, it creates some pressure difference and that creates a lift? Do you remember that, my warriors? So just use that right over here. That's it, just use that right over here. So let's see, think about it over here. So we have the wind which goes from the top and one which goes from the bottom. It creates a lift, and remember I told you that lift is due to the pressure difference and into area. Lift is pressure difference into area, and this lift will be exactly balancing the weight. That means it will be mg. This lift will be equal to exactly mg. That's it. So let's see what we can do now. Use Bernoulli. That's it. Just use Bernoulli and let's find out pressure difference. P1 plus half rho 1 V1 square is P2 plus half rho 2. Rho 2 is same, so no need to put rho 1 and rho 2. So half rho V1 square, and this is just half rho V square. Since the plane is in level flight, H1 is equal to H2. So very important, so I have not put H term over here. So from this, what I see, the pressure difference is basically half rho. Okay, half rho is common. P1 minus P2 is basically half rho. You can call it as V1 square minus V2 square or V2 square minus V1 square, whatever you want to call it. Bigger number minus the smaller number. That's what pressure difference is. So now just put the values. Is the density given? Yes, it is 1 kg per meter cube. Fair enough. The bigger speed and the smaller speed. The bigger speed is 50, the smaller speed is 40. Do you see that? Yep, the bigger speed is 50 and the smaller speed is 40. So it will be nothing but 50 square minus 40 square. Fair enough. Now I can take out 10 common, 10 square common. So 10 square is outside, divided by 2. That is 5 square remaining, which is 25, minus 4 square, which is nothing but 16. So 100 by 2, that's 50. And we have 25 minus 16, which is just 9. So this will be nothing but 450. This is pressure difference, so Newton per meter square. Once you get pressure difference, you can find out the lift. From lift, you can find out the mass, because they both will be equal to cancel it out. So let's do that math and see what it is. Pressure difference into area. So 450 into area. What is the area? Area is 25 meters square. So many of you are going to put just 25, but be careful. The word each has been used. How many wings are there? 1, 2. So 2 wings. So 1, 2. So basically it will be 25 into 2. Many people forget to multiply it by 2. You will get a wrong answer. Is equal to mg. So therefore 450, 25 2s are 50 is equal to mass into g, which is just 10. 0, 0 goes. So m will be, just check this out. How much are you going to get? 450 into 2. I think 45 5s are, that's 225. So 225 into 0 kg. That is the answer. Is it there somewhere? Yes, it is. Option C. Done, done, are done. Got it? So this is how you can calculate. And now you are a true engineer. If you know the speed, somehow if you decide the speeds on the top and the bottom, using Bernoulli's, you can now calculate how much mass can be the plane. You know it. That's what engineering is all about. Or you can do the reverse way. If you know what's the mass of the plane, you can calculate what should be the pressure difference. From that, you can calculate what should be the speeds on the top and at the bottom. Beautiful, isn't it? That's how engineering works. It's all about calculating and solving real life problems. This was a very nice real life problem. Did you love it? If you're loving it, make sure that you smash the like button down there. Okay, let's talk about the next part. 2 very important applications. One is Torricelli. Yes, NE18. Many people miss that each part. Velocity of a flux, or Torricelli's law. It's after the guy who actually gave this law and derived these equations. So imagine you have a container and it's full of some liquid. The height till which the liquid is there is h, and there is a small hole which has been drilled over here. What is this? This is a small hole which has been drilled. The water is going to come out. It's going to eject. That is called as efflux. Okay, that's called as efflux. The small hole is called as an orifice. So orifice is a small hole. Efflux is the flow through that hole. The water is going to flow and it's going to strike somewhere. I'm interested in three different things. One, what is the speed of the efflux through that orifice? Number two, what is the time that it takes to fall down? Number three, what is the range of that efflux? I know one thing now. If I want to find out speed, if I want to find out time, and if I want to find out range, this looks like projectile motion, your initial days of 11th standard, isn't it? And you throw something from some height, it falls somewhere. You know the height of the tower, you know where it lands, you can find out the time of flight, everything, if you know the speed of projection, horizontal projectile. So that means you just need to find out speed, everything else will follow. Alright. So what and all applications of Bernoulli you need to do? Think, how will the streamlines of the liquid look like? The streamlines of the liquid will look something like this. It will look like this. It's all collecting over here. This is one cross section, this is second cross section. So I hope you can see the pipe from wide to narrow. Here the area of cross section is A, which is much larger than this small a over here. This is small a, which is the area of cross section of the orifice. The small a is for the orifice. Now, if I apply Bernoulli's principle, here is what I will do. I will take, this as my reference line. Okay, this as my reference line, and then according to that, we will write down the Bernoulli's equation for this cross section and for the narrow cross section. Everybody with me? Okay. Now, here it is. First, pressure. Imagine somebody is applying some pressure from the top. Somebody is pushing that liquid with P. So it will be just P plus rho G height from the reference line. Can you see this small h? This is the center. This is the reference line. The height of that cross section is small h. So rho GH plus half rho V1 square. This is at the top is equal to, once it comes out, it is open to the atmosphere. So the pressure over here is just the atmospheric pressure PA, P0, whatever you want to call it, atmospheric pressure, plus rho GH. This cross section is on the reference line. So what's the height going to be? It's just going to be 0. Make sense? Last term, it's going to come out with some speed. So half rho V1 square. Alright. Oh, sorry. I think V1 is already used there. So let's use this as just half rho V top square. So that we are clear with the symbols. V1 is the speed here. V top is the speed from the top. Don't you guys see, because this is a very large surface and all the liquid is flowing through a small orifice, even though the liquid comes out with good speed, the speed with which this comes down is very small. Don't you see that? The speed Vt is very small. It will come down slowly. If it comes down slowly, it will be in very small decimal numbers. Then the square of a decimal number is even small number. 0.1 square is 0.01. Correct? So the square of a decimal number is even smaller. So this term will become negligible. It's negligible. I hope everybody agrees with this statement. That means, what do you need to do, my warriors? Think now. Hi Rihan, welcome. I'm guessing you were there yesterday too. Piano, it is not possible to crack JEE in 1 month unless you are a superhero. So better join the crash course and crack it in 2 months, because you still have time. At least 2.5 months are there before the first attempt. Okay. So just do the math. So you'll get P plus rho GH is equal to PA plus half rho V1 square. So turn the terms around. So bring PA over here. So P minus PA and you will multiply it by 2 times plus 2 times rho GH is equal to rho V1 square. Bring the rho below, so it will become 2 times of P minus PA divided by rho plus 2GH is equal to V1 square. So therefore, I will get V1 is equal to, think about it, 2 times P minus PA divided by rho plus 2GH. This is what you need to remember. But most of the times you don't have to remember even this equation because most of the times the container is open. So if the container is open, that means this is open to the atmosphere. So what will happen? This P will be equal to P naught, or the atmospheric pressure, PA, whatever you want to call it. So if these two numbers are equal, the subtraction will be 0. So this entire term will vanish, and therefore V1 will become root of just this term, which is just 2GH. That's what you're going to get. Done. Yeah, that's it. AKIIT, no. For modern physics, NCERT is definitely not enough. If you want to crack modern physics, you need to go through HC Verma, PYQs of Arihant, Tattva module, only then you can crack it. If somebody has told you only NCERT is enough, they are lying to you. Okay, so please don't listen. So root 2GH, what is H? H is the height from the top. This is when container is open, and most of the times the container will be open only, don't worry. So that's the formula, root 2GH. Now let's talk about the range and the time and all of that. Now that one is easy. Okay, so we just found out the velocity of efflux V1 is root 2GH when P is equal to PA. Basically it is open. So most of the times it will be open only, so don't break your head over there. What is the time of flight? The time of flight, we all know, is basically root of 2 this height of the tower, 2 times of height of the tower basically, okay, divided by G. That was the formula. So essentially what will be the time? The time will be root of 2 into H minus H divided by G. So that's what the time will be. You don't have to remember this, this is obvious. Last thing, what will be the range? The range is horizontal, so it's the horizontal velocity. The horizontal velocity is always this V, okay, this V or V1. V is always same, remember it never changes. So V into time for which it flies. So hence it will be V1 into T. So let's see what happens. V1 is root of 2GH and time is nothing but 2 by G root, and you have H minus H. You can clearly see from here G and G cancels, 2 2s are 4. So hence you are going to get the range as root of 2 times H into H minus H. That's what you are going to get. But I don't like remembering the formula this way. In fact, think of it like this. I like to remember the formula like this. If this is H, okay, if this is H, let's say I call it, H. This one, I can call it as H prime. I can call it as H prime. H and H prime. H plus H prime gives you total height. So H prime is the complement of H, because H prime plus H is the total height. If this is this much, that's the remaining height. If this height increases, this height decreases. They complement each other to add the total sum to be H. Like you have complementary angles, 20, 70, 30, yeah. So like that, 20, 70, 30, 60 and all of that. So same way, these are complementary heights. Now, over here, I would love to remember this formula like this. So the range will be, oh sorry guys, I just forgot one more 2 over here. So sorry, this was 4 times. Yeah, this was 4 times of H into H minus H. So the range will be 4 times of this H and into H minus H, which is the complementary. So basically H prime. So that's how it is. It's very easy to remember. Is it clear, my warriors? Is it clear? Yes, velocity vector is like a projectile motion too. Yep. So the range is just like 4 into h prime. H is one height from the top, h prime is the other height from the bottom. It makes our job easy. So that's how you can remember it. Fair enough, my warriors. Now, this is another important result. The range is maximum for h by 2. Why does it come and from where does it come? See, we all know for complementary heights, the range should be same. Now, why is it true? Because the range was just root of 4 into h prime. So, imagine I drill a hole here from the top. Okay, I drill a hole here from the top. Now, this will be h, this will be h prime. This will be h, this will be h prime. Imagine from the bottom, I drill a hole from the same height as the depth below the water. So whatever is this height, at the same height, I drill a hole over here. So now this will become h and this will become h prime. Now the new range will become h prime h. It will have 4 here and h prime h. I hope you understand it. From the top, the depth will be h prime. From the bottom, it will be h. Don't you see it's the product which matters? Don't you see it's the product which matters? So the product will be same and hence the range for this guy and for this guy will be the same. I hope you understand it. So if you drill a hole from the top at some height and you drill a hole from the bottom at the same height from the bottom, you will see the motion will have the same range. Perfect. Like, projectile motion. For complementary angles, the range was same. So if you draw the different scenarios, like from the top it comes here, from the bottom it goes here, from here it goes here, it goes here. So when you drill the hole at the exact center, the range is basically maximum. That's what happens. Okay. Nanga Tamila Tarilya Ashwin. Okay, chalo. Let's get going to the next one. Is it clear, everyone? Shall we go ahead? Okay. So beautiful concept that the range is maximum exactly at the center, and for complementary heights the range is same. Let's see how many of you are paying attention. The first question coming up on your screen, and here it is. Let's see how many of you can get this. Perfect. Come on, my warriors, figure this out. Okay, is it B? Yup, it is B, my warriors, because I just told you. See, you're drilling the hole from the top and you're drilling the hole from the bottom, and they both are falling at the same place. So the range is same for complementary heights. For complementary heights. So if this was 1 meter and if this is 9 meter, then this is 1 meter and this is 9 meter. So it's always complementary. So that means it should be 1:1. Correct, Shyam. Hello unknown, welcome aboard. Next question, it's very crucial because it's going to open your eyes and a very interesting way to solve the problem. This was asked in 2014. It's JEE previous year question. This tank has partial water and partial kerosene floating over it. Water's density is 1 gram per cc standard. Kerosene's density is, 0.8 specific gravity. That means it will be 0.8 grams per cc. Now, here it is. The question says, if the hole is open at the bottom, like right over here, what do you think is the speed of the water going to be approximately? They are asking you what is the approximate speed. Now, first of all, the formulas that I have given you is when the liquid is same inside. Okay, so when there is same liquid inside, then you know the velocity is root of 2gh. But here is the problem. Partially it is water, partially it is kerosene. So I have a nice trick in mind and use this because this concept has come more than once in the JEE exam. I am repeating, this is a very important concept. In JEE, the same concept, mixture of liquids, has come, and many people still use very, very lengthy methods, but I am going to teach you a very smart trick. What is the trick? The trick is, whatever is the liquid on the top, convert it into the liquid which is there below. So, whatever liquid is at the top, convert it into the liquid at the bottom. Okay, what do I mean by that? Is, see, the kerosene has less density. It's having a height of 2 meters. If instead of kerosene you use water, then to produce the same pressure effect, instead of kerosene, which is lighter, if you use water to produce the same effect, do you think you will need more water or will you need less water? Lalita, don't worry, just follow whatever I am teaching. Just follow the lectures, watch all my lectures which are there on JEE Enthuse channel, the playlist. You will slowly cover up your backlogs. You have a lot of time, don't worry. Even if you have wasted time, now is the right time to begin. You have to start somewhere, but don't give up. What do you think, my warriors? If you want to convert kerosene into water, do you need less of water? Do you need more of water? Because kerosene is lighter. If you convert it into water which is heavier, you will need less amount of water. So that's the concept. So the pressure of kerosene should be similar to the pressure of equal or equivalent amount of water. Equivalent amount of water. What is the pressure of kerosene? It will be density of rho gh. Density of kerosene G into H. What is density of kerosene? It is 0.8 gram per cc. Specific gravity and grams per cc will always come out to be the same thing because this is relative to water. This is kg per meter cube, which is actually 1 gram per cc. That's in CGS unit. What's the height of kerosene? Height of kerosene is 2. What is the height of water that you're going to convert it into? I do not know. Let's find that out. Density of water is 1. G is G. Height of water is going to come from here. So that height will be 2 into 0.8, which is 1.6 meters. That means instead of having 2 meters of kerosene, you can have 1.6 meters of water. So at the end of the day, how much water you have over here? How much water do you exactly have over here? You have 3 plus 1.6, which is just 4.6 meters of water. This is exactly same. There is no difference in that. These both are exactly equivalent. Yes, Vivek, your comments are visible. Yep. That means now I can easily find out what is the speed with which the liquid comes out. That speed will be root of 2g h equivalent. So g is 10, height equivalent is height equivalent is nothing but 4.6. 46 into 2, that's going to be 92, right? Root of 92. Now look at the options. Root of 81 is 9, root of 100 is 10, so it will be between 9 and 10, so hence that should be 9.6, as simple as that. Yep. AKIIT, you should watch Nurture series for 2022. Well, for 2022, if you have less time, then yes, you can watch Flash series. But if you want some topic in detail, then I would suggest watch for only that topic, watch the Nurture or the Pathfinder series. Cool? So that's how you get the answer. What a brilliant question of converting kerosene into water and then treating it like one liquid to solve the question. So that's the method used. Perfecto. So Teja, you are a little late. The droppers batch have already started long time back. So the only option left for you, Teja, now is to join the crash course for 90 days, and that's how you can improve. Okay? Because yes, you are going to have test series and all of that. So even now you have time via the crash course, because even if you join the dropper batch, half the things would be over and you will get more demotivated. So it's better to join a new batch which starts from the beginning, and you can see there is a link in the description box, or just ping me on Instagram. Next question. A cylindrical vessel of cross section which contains water till certain height. There is a hole at the bottom. How much time will it take to empty this? How much time will it take to empty this container? It's very interesting. This is very, very important question. So observe it. Now, okay, I don't think I need these options because these options look scary. So let's just get rid of these options. The first thing that should strike your mind is that the liquid which will come out of this hole will be root of 2gh. Like, sir, I think I know this. I know the speed. I know the area. I know how much volume is coming out per unit time. If I know how much volume is coming per unit time, I know what's the total volume. I know what's the total volume of the container. So I think I know what to do. If this much volume is coming per unit time, if I multiplied it by that time, I'll get the total volume of that container. So from this, I can find this out. My question to you is, do you really know the volume which comes out per unit time? You'll be like, yes, volume which comes out per unit time is area of cross section, in this case it is small a, into the velocity. And I know the velocity. I'm like, yeah, fine, but think again. You cannot use this reason. The speed is not constant because the height will keep reducing. If the height keeps reducing, speed keeps changing. If speed keeps changing, this keeps changing. If this keeps changing, how can you apply this? It's changing every time. So we need to do some magic over here. I think we might need derivatives or integration. Do you get that feeling from inside? How many of you got that feeling that probably we are going to need derivatives and integration? Sincerely. After I spoke about this, now are you getting it? Hi Alka, welcome. Are you getting that feeling now? And if you're getting that feeling, good. So let's see how to do this. First, let's just assume when it is at any random height, let's say that random height is just x. The speed with which that liquid comes out is, let's say, u, and the speed with which this surface goes down is v. But that speed will be very less. It's going to be very, very small. Keep this in mind. Slowly it's going to come down. It's going to take a long time. So, well, Sundar, I think it's my passion towards teaching and my love towards the subject and your support and your love that's keeping me standing. Okay, cool. So let's get going. Now, let's see if I can somehow write this velocity in terms of x. I think I can, because this velocity which is coming down will be dx by dt, but with a negative sign. Why negative sign? Because it is decreasing. X is decreasing. Remember, x is decreasing, so minus dx by dt. Minus dx by dt will be velocity. How I can relate v and u? Because I can find out u for sure. U will be root 2gx. X is the height at that instant. This x is at any instant. This is at any instant. How much ever liquid is remaining. Now I know u. How can I find v? Continuity. Yes, use continuity. So using continuity, what will I get? I will get big area. What is that big area? It was A into V will be equal to, the small hole has a radius of A, so it will be pi A square into U. Perfect. That's all I have done. I have just used continuity equation. Let's start substituting all these numbers and see what do we exactly get. So we get A, velocity was dx by dt is equal to pi a square. What is u? U was root of 2gx. Wow, I think I know what to do now. Do you see this? I have x over here, I have dt over here. Probably if I rearrange this, I might be able to just integrate it with the correct limits, and probably that should solve the problem, right? All my warriors with me? Let's move on. Let's just move this now. Shift this a below, shift the root x this side. So therefore it will become 1 by root x into dx is equal to, or just put this as it is, put the pi a square over here. So a by pi a square, and put the root x and root 2g also here. So root of 2gx as well into dx is just equal to dt. Rearranging it further, see what do I get? I'll get a divided by pi a square. Root 2g will be as it is. Root x is x raised to half. So when it goes on the top, it will become x raised to minus half. And we have dx over here and we have dt over here. Cool? Now the reason why I wrote it like this is because I want it in the Sundar form. We just had a guy named Sundar. Sundar form means beautiful form. That means all the x's are on one side, all the t's are on one side. So you separate the variables to prepare it for integration. So now let's apply the integral symbol here and here. Oh, there is one mistake. I had to put that minus sign. So let's just put that minus sign as well. So minus as well. So we'll have minus here. We'll also have minus here. So we'll put that minus sign because v was minus dx by dt. What are the limits? When you just start, that means time is 0, x is h. It starts from here. So x is basically h. When you wait for some time, that means t time, then the value of x becomes 0. That means it's completely empty. So that's why these will be the limits of integration. Everyone fine till this point? Very good. So let's just move on and see what do we get next. I'll just put a division here. So minus a divided by pi a square root 2g is as it is. X raised to minus half's integral, in case you have forgotten what is x raised to minus half's integral, it is basically x raised to minus half plus 1 upon minus half plus 1, which is x raised to half divided by half, which is basically 2 root x, which is 2 comes on the top and x raised to half is root x. So it is basically 2 root x. That means I should put 2 root x, and here I should put h and 0, and here integration of time is just t, so t, and over here 0 and t. Now it's simple integration. Let's just see what happens. 2 just comes outside, so minus a into 2 divided by pi a square root of 2g. Root of x, you first put 0, so 0 minus root h is equal to t minus 0. So t minus 0 is just t. Minus minus will become plus. Root 2 will cancel. So a root 2 h divided by pi a square, and you have root g. I think that should be the final answer. Yep, that should be the final answer. One of the root 2 got cancelled. So this is the time it takes to completely empty it. This kind of question can be asked in JEE Advanced. Surprisingly, it was also asked in JEE Mains once. Okay, but this was one of the tough questions for JEE Mains. But for JEE Advanced, this should be like a standard or an average question. Everybody with me? Done, done, are done? Can we go to the last topic of today's class? Yep, let's go to the last part of today's session. But before that, a simple question. So Mohammed, just prepare for JEE Mains examination. You automatically prepare for West Bengal JEE, Maharashtra CET, Karnataka CET, every a state CET. Okay, so you don't have to prepare for it anything specially. JEE is the exam for everything. Two diagrams are given. There is a liquid here and there is liquid here. You can see the liquid is less, more, less at both these sections. Question is, one of the diagram is wrong, one of them is correct. Which one is wrong, which one is correct? Come on, post your answers in the comment section. I want to see all of it. Come on, my warriors, think carefully. What do you think should be the correct answer? Figure this out. There's only one answer which is correct, one answer which is wrong. Figure this out. Come on, figure this out. Look at this. The pipe is small here. The liquids are different in height. What is causing that difference? Try to analyze. Use Bernoulli's principle. Somebody is saying B is incorrect, A is correct. Think, I have mentioned about Bernoulli, which said when height is same, you can see the height is same, then what happens is P plus half rho V square is constant. That means when the area becomes small, you can see the area becomes small. What should happen? By continuity, the speed should increase. How am I arriving at this? This is my continuity equation. So if the speed increases, pressure should decrease. So this point should be at low pressure. If this point is at low pressure, the water should not go up so much. It should be at less height. The water should be at less height. So there will be low pressure here and this will be high pressure. Is that understood? That's why that diagram is correct. Perfecto, my warriors. Yes, figure A is not possible, B is possible. What you have just seen now is nothing but Venturi meter. This is exactly Venturi meter. Venturi meter, you have a small passage, a constriction, and because of that, you will see a pressure difference. And that pressure difference can be found out by the height difference. And from the height difference, you can find the speed, you can find the volume which flows through these parts. So that is called as a Venturi meter. Look at this. The liquid is forced in a smaller section and again it comes back. This device is used to measure how much liquid is flowing in it. You can see there is a manometer over here. Look at this beautiful manometer. You can see the manometer is going to show some height difference because there is some pressure difference. So measuring that pressure difference, you can measure the speed and everything else. What kind of equations you will need? You will need equation of continuity. Equation of continuity, that's the first equation. Second, you are going to need the Bernoulli's principle. You are going to need the Bernoulli's principle. And the third thing that you are going to need is that the pressure difference is going to be given by the manometer. These are the only three things you need. From these three things, you can find out how much is the speed of the liquid. You can also find out what is the rate at which the liquid is flowing. So I'm just going to give the formula, but remember these are the three things used for deriving it. And the formula for the volume flow rate, very easy to remember because it is very symmetric relationship. Yep. The speed of water, no, the speed of water is not needed. Yes, these two things are not needed. In fact, you can find them out just by measuring the height and if you know the densities and the areas. So what and all you need to know? You need to know the H. What is H? H is the height difference here. The height difference here. What is A2 and A1? A2 is this area and A1 is basically this area. You can find the volume which is flowing per unit time. Volume flow rate. A1, A2, very easy. Come on, let's remember this. A1, A2, root of 2GH. Usually you had root of 2GH over here. Here you have square, square, that's it. And the product of the same terms. So A1 square, A2 square, you have A1 into A2. That's it. That's the volume flow rate. Keep this in mind. Everybody ready for solving a question? Now, before we solve a question, you might be wondering, sir, what is the use of this? This is used to measure how much volume of liquid is flowing in. Believe me, it is still there even today. By chance, if you live in big cities, okay, like Mumbai, Delhi and Chennai and all of that, then you will see the pipes suddenly come out of the ground and at some place the pipe becomes narrow and then again it becomes big, and there will be something attached over here, okay, and there is some meter and something like that over here. You might have wondered what is this, but maybe you might not even have bothered about it. Next time you see it, you will remember that this is a Venturi meter that is just used to see how much liquid is flowing inside the pipe. Okay, just see this. Is it works for real fluids? Yes, infinity. It is. It is. I'm so glad, Tarun. Now stay with us. JEE and all the other exams will be easy. BIDSAT, VIT, EEE, everything. Okay, so don't worry about it. All right. So let's talk about the final question on Venturi meter, which was asked in 2014. In the diagram shown, the difference in the two tubes is 5 centimeter. The cross section at A and B is 6 millimeter and 10 millimeter square respectively. What is the volume flow rate? What is the volume flow rate? Come on. I think you know which formula to use. Come on, my warriors. Which formula are you going to use? Remember the formula which I just gave you? That's it. The volume flow rate is A1, A2, root of 2GH, and you have A1 square minus A2 square. Just substitute every goddamn thing out here. What is A1? A1 and A2, 6 and 10. So 6 into 10 to the power, that's millimeter. 1 millimeter is 10 to the power minus 3 meter. So square, so minus 6. So 6 into 10 to the power minus 6 into, that's 10. So 10 into 10 to the power minus 6. Fair enough. Root of 2G. What is G? G is 10. Okay. What is height? Height is 5 centimeter. So that's going to be 5 into 10 to the power minus 2 divided by A1 square minus A2 square. So bigger minus smaller. So 10 into 10 to the power minus 6 whole square minus 6 into 10 to the power minus 6 whole square. Crazy looking numbers, but it's easy. Let's try this out. Okay, so we will have 6 into 10, which is basically just 60. Let me just put 60 over here. 60 into 10 to the power minus 12. Over here, 5 2s are 10. 10 10s are 100. 100 into 10 to the power minus 2, 1. So the numerator just becomes 1. Good enough? Okay. 10 to the power minus 6, 10 to the power minus 6 is common. So the square of it rather. So when you take it outside the root symbol, it will just become 10 to the power minus 6. Make sense? What is remaining inside is 10 square, which is just 100, minus 6 square, which is just 36. Everybody agrees? These two numbers cancel, so it will become 60 into 10 to the power minus 6. 100 minus 36 is 64. Root of 64 is nothing but 8. Correct? So this is going to be, yep, just 8, I believe. Fair enough. So 6 by 8 is 30 by 4. So that's 30 or 3 by 4, and I think we have everything as 10 to the power minus 6. Okay, so let me just keep it like this, into 10 to the power minus 6. So 3 by 4 is 0.75. 0.75 into 10 is 7.5 into 10 to the power minus 6 meter cube per second. Understand 1 cc is 10 to the power minus 6 meter cube. 1 centimeter cube is 10 to the power minus 2's cube, because 1 centimeter is 10 to the power minus 2, cube of that 10 to the power minus 6. So this is going to become 7.5 cc per second, which means option A should be correct. Option A is correct. Yep, it is. It should be. Got it? So the formula that you have used is this. If you know that formula, you would have definitely cracked that question in JEE. That's what it is, and it's all about knowing the formula, substituting the correct values, being very sure about your calculations, and being very, very focused on that problem. That's all. Yes, Jyotsna, that's correct. Now, I have few questions. This is one question which you need to leave it in the comment section below. This is your second question which you need to leave it in the comment section after the session is over. You can take a screenshot. This is your third homework question for today. Remember why you need to solve these homework questions. These are like assignments so that you know that you have got it. And these are the students who have solved the assignment last lecture. So let's go back over here. Where are we? Yes, lecture number 2. That's fluid dynamics. Look over here. Very good, Ishpreet. Very good, Dakshin. Very good, Yash. Very good, Saja. Very good, Chandan. Gokulnath. Very good. Shubham has loved the session. Thank you, Shubham. Very good, Harita. And I wish you guys, I'm coming back. I did not manage my timetable in few days because of my exams. It's okay, Yash, but be back very soon. We are all waiting for you, okay? So I'm giving you that heart right over here. Okay, hemisphere wala questions, Sushila. Okay, I'll put up the solutions in the Telegram. So please join the Telegram, Sushila. And all the best, Yash, for your exams. And yes, most of your exams are ending on Friday. I can see that. Perfect. So I'll be waiting, and make sure that you check out the playlist right over here. It's there. Check this out. This is the playlist for all the Pathfinder. Okay. Now, also very interesting thing that you need to know is that when you're watching this video, there are very interesting links in the description box as well. Like, you can see right over here, you have the link for the Telegram channel. You have the previous playlists as well. And you will see that you have this most important link, which is for joining Vedantu, where if you want my courses, my micro courses, not just mine, other teachers, and all the important courses like KVPY, and you want to prepare yourself for JEE along with boards, you don't have to run to 2-3 institutes, 3-4 teachers, pay everywhere, and you don't have to join test series separately. Everything under one roof. Just click on this link. You will see topic wise short courses, the entire 11th standard syllabus, and then you will have your 12th standard, and also all the other courses for free of cost. All our classes are live plus recorded. That means if you miss a class for some reason, then you can always watch it in the recorded form. Test series analysis, of course, assignments and notes, so you don't have to struggle for notes even if you miss a class. You get the PDF, assignments for every class, and test series, which is very important to track your scores. Doubt solving in the class, that means you have 2 teachers in the class, one who is teaching, one who is just solving your doubts. And after that, on the mobile app, you can ask unlimited doubts from any topic to clear your concepts, so you don't have to struggle on Google. And if you want personal mentorship, that's available in the Plus version 2, and Classic will give you the doubt solving. Guess what? Even the lightest version is so cheap, and even the package which includes everything is so cheap. I'll tell you why. Because the highest one is 2,700 per month. The lowest one is 1,350 per month. It's dirt cheap. Though it says 15 days, technically it's for 30 days. You get 15 days extra when you use only my coupon code SHHPRO. And you get additional 10% discount, and if anything goes wrong, you can obviously get in touch with me to resolve the question. Alright, so that's our pro subscription. Try it out for 15 days, and if you want any of the other packages too, you can try it out for 15 days, and you will get more 15 days with my coupon code. Remember that. So I'll be very, very excited to see all of you, because right at your fingertips, right at your home, you can study. You don't have to travel anywhere, and you can reap all the benefits where you don't have to run around multiple coaching institutes with the best prices. You cannot compare these prices with any offline or even online industry. I mean, look at these prices. Even a tuition teacher charges more than these prices per month. And we are giving you all the subjects with test series and all the materials. So I hope you guys had a great time. Bye-bye NV18, Bharat. Bye-bye Wiki. Yes, optics, I'll be doing Wiki for 12th standard in January. All right, I'll be doing it in January. The term 2 syllabus, Jyotsna, have already started for 12th standard. I have already completed EM waves. I have already completed light waves 2 lectures. I'll be doing the remaining part next week. Light waves will be done. So 2 chapters will be already done for term 2. Modern physics, semiconductor, and ray optics. Those are the only 3 things remaining. I'll complete it within the first half of January. Don't worry. Thank you, Jairo. And 12th portion will be done before Republic Day, much before Republic Day, don't worry. JEE 2022, now for those of you who are interested, I'm going to post a new video just in some time, so stay tuned for that. Yep. Have a great time, and bye-bye Jacob, bye-bye Jyotsna. Take care, have a great time, and do not forget to smash the like button and follow me on my Instagram. Have a great time, my warriors. Time for dinner. That's it from my side. See you again tomorrow at 7 o'clock. Hasta la vista. This was Captain Shreyas and I was going live.